Welcome to the Jack Westin MCAT Podcast with your host, Phil Hawkins.
And Azaii Calderón Muñiz.
All right, welcome everybody. I feel like we have kind of started something. Those of you who've been, watching the podcast religiously noted that, like in a previous episode, we were talking about, we want to kind of experiment with being able to show things on the screen and kind of see how you guys like that. There's a reason for this. There's a sneaky reason behind all of this. Azaii and I have been talking a lot, just like not just over the course of the podcast, but about MCAT stuff and everywhere. We've been working together for years, and there is something to be gained from understanding the test writers, the AAMC writers, like what it is, how do they think, how do they put together questions, how do they structure the exams, like what is it, like trying to get into their heads. That's something that we have tried to do a lot of as we go through and kind of like talk about different content, like hormones or like all the psychology stuff or, different like physics topics. But there is something really important about seeing practice questions, seeing how the test writers are actually testing these things. And so this is a big thing that we're going to start something new. And today is the first episode of hopefully a whole bunch of episodes where we are going to go through actual AAMC questions that have been written by the exam test writers. Now, this is something we're trying to figure out, how do we do this? Because the AAMC has a lot of stuff that it's all theirs, like it is their material, right? Like that they own, and we can't distribute that without their insight. However, there is one thing that they give out freely, and that is the AAMC sample test. And so we're trying not to step on the AAMC's toes because we definitely want to be able to, work with them long term, right? Obviously, that's a bridge we don't want to burn. Mm-hmm. This is a topic that they are perfectly okay giving out these free resources. So we're going to go through the AAMC's sample test, the unscored sample test. And we're going to go through it and we're going to talk through every passage, every question, every discrete question, like what is going on in the test writers' heads and how can we break this down? I think that a lot of students, when they're reviewing, they tend to just review like in a big, like cursory glance and not dive into understanding the test writers. So this is going to be a little bit different. We're going to be reviewing this the way you should be reviewing your exams. And hopefully you'll gain a lot of insight from hearing us talk about this, because I am super passionate about this. And I think that there's a whole lot to learn from some of these AAMC questions and passages about how you're going to get tested on test day.
Yeah, this is something that we've worked so hard to drill into everyone's mind since the start of this podcast. So I'm really excited to finally see this project come to fruition because we have talked about it so much. But yeah, we've always emphasized how important good review is and great review in order to identify weak areas, but also to really just understand how to approach each section. And so I'm really, really stoked about this. And I know Kemph is your jam. So so I'm excited to get to partner with you on this. Because like you said, we've been working together for quite some time.
Yeah.
Whereas I don't think we've sat down and done sciences together, aside from a couple of podcast episodes. A long time.
Yeah. I'm excited to sit down and go through, hear kind of your thoughts and have you hear my thoughts, just kind of going back and forth. And I think this will be valuable for students, for them to be able to see MCAT masters, how do they tackle exams and how do they look at things.
For sure.
So I guess without further ado, I'm going to go ahead and hop in here. So we have this passage here, multiple paragraphs, multiple figures. You can kind of see from this overall, there's a lot of organic chemistry looking things in here. I realize this is probably too small for you guys to see, so I'm going to zoom in here a little bit so that we can kind of go through this passage and the questions associated and break this down. So I guess without any further ado, we should probably just hop in. I'm so excited to be doing this. We've been talking about doing this for months and kind of like building up to it. So just kind of diving in, we have this first passage, 4 questions. HIV protease is an example of an aspartyl protease. I'm going to pause here. Man, we are not moving very fast already. The moment you see this, there should be an alarm going off in your head of aspartic acid, right? That they tend to like add YL to things as a way to show like it's a different form of that. Like an acetyl group is related to acetic acid, right? Or a formal group is related to formic acid. Aspartyl is related to aspartic acid. And so that's something that should be going off alarm bells. We talked about this a lot, but like amino acids are the single highest yield thing on the day of the test. So anytime you see anything like that, you should be immediately thinking, okay, there's something going on here. We're talking about an aspartyl protease. This is something that cuts like aspartic acids. Now, if you didn't catch that, it's okay because they go ahead and clarify this. They say it's an enzyme that utilizes an aspartate side chain during the catalytic cleavage of a peptide bond. And so actually, it's a little bit different than I originally thought. I assumed that this something cut aspartic acids, but it uses aspartic acid and its conjugate base, aspartate. Same thing as aspartic acid. Aspartate is just missing the hydrogen. Aspartic acid has the hydrogen on it. It uses aspartic acid to cut a peptide bond.
Yeah. And there's so much even in this first sentence, right? This is the first sentence of the exam. And what you're seeing is you're already seeing some biochem in chem phys, right? You're seeing amino acids and enzymes and already catalysis, right? Catalytic cleavage. And so this is something that the AAMC writers love to do. It's connect different topics in a single passage, right? And so, we've always emphasized kind of crossing topics in your mind whenever possible. And this is why, literally first sentence, first passage in the exam.
Yeah, this is why we always encourage students to be studying all the topics simultaneously rather than try to study physics and then knock that out, and then biology and then knock that out. You want to be connecting these themes. And we haven't even talked about the fact that we're talking about HIV, which is a virus. And so we have virology, we have amino acids, we have like catalyzing reactions, we have enzymatics, all of these things, super high yield. You want to make sure that you've got a good understanding of them. But overall, we just have this enzyme that uses aspartic acid to cut stuff. Since HIV protease is a relatively small homodimer of a 99 residue protein, I hope those of you who are reading this, alarm bells are going off in your head because that is something that they would like to ask a question about. If you ever see anything about homodimers, heterodimers, homo just means same. Like dimer means 2 of them. So it's 2 of the same protein that come together. You could also have a heterodimer where you have 2 different proteins that come together. And it can be directly synthesized or cloned and expressed in fast-growing cells. For this reason, it was targeted for structure-based drug design in order to treat HIV infection. There's a whole lot of stuff going on here.
And there's something really beautiful in this sentence. They give you a clue as to what's going to be important. They tell you for this reason, right? It was targeted. And then they tell you for structure-based drug design. And you can see ahead that there is a structure, right?
Yeah.
And without even scrolling down to the rest of the passage. And that can be a hint that, I could get a question about one of the structures that I'm seeing. And so something that I hope you realize that we're doing is we're essentially looking for these buzzwords that can hint at what topics they might ask us questions about. And so as you're reviewing, when you're taking the exam, yes, look for those. And then also when you're reviewing, go back and identify them so that you can get better at identifying them in the first place when you first see them on test day. But absolutely, Phil. So we have information about this, enzyme that's using aspartic acid to cleave the bond. It's all in the context of HIV and treating HIV infection.
Yeah, I do think I also want to just take a minute and mention your scratch paper and what you're using your scratch paper for. I think in stuff that gets into a lot of like weird enzymatics, it can be really useful to do a quick sketch of kind of like what's happening here within this. So like obviously like if I had a piece of scratch paper, you couldn't see that on the board or on the screen here. So I'm going to go ahead and just kind of like write on here, but I'm definitely going to draw like this homodimer like this is the HIV protease, right? HIV, and I'm going to just like protease in here. And so this thing is going to come in here and cleave like a peptide. So if we have some peptide, this is going to come in here and cleave that and break it into two pieces. I do want to just take a quick mention, like anytime they mention amino acids, right? And they did mention aspartic acid here, that should be setting off alarm bells. So I'm going to go ahead and note that there should be an aspartic acid somewhere in this. I think a lot of students are going to get this wrong. Where are we going to expect to see that, right? Are we going to expect to see it in the peptide that we're cutting? No, right? Because this is an enzyme that uses the aspartic acid side chain when it cleaves something else. So my aspartic acid is going to be on this, and E is the one letter symbol for aspartic acid. So if I'm doing this on my scratch paper, I'm going to go ahead and throw that E in there. So something to keep in mind, like if you're looking for a quick way to just kind of, like do a quick sketch, I think that this image is way easier for me to understand than this whole paragraph. And if you can take a paragraph and you can like summarize it into an image, I feel like a 5-year-old sometimes. So just like, give me a picture instead of a paragraph. And like, that'll make it easier for me. Yeah, a third grader. Exactly. And so it allows you to simplify this stuff overall.
There's a lot of overlap, right, with CARS that I don't think students realize in terms of the strategy and that simplification, and looking for what's testable. And so that's why, again, we always encourage you to approach each section kind of parallel when you're studying.
Yeah, especially when one thing starts to apply to a lot of places, that feels good because it's more useful that way. And that's why the way we like to kind of teach this is like, we'll teach you one thing that you can apply to all the scenarios.
Exactly. So moving on a little bit down. So we're told a portion of the peptide cleaved by HIV protease is shown in figure 1. And so when you see a figure, you always want to make sure that you read whatever title or description you are given for a figure. And so in this case, we're told that the peptide bond cleaved by HIV protease. So we've been told that this is the peptide bond twice. And now we know, okay, this is the amino acids that I could get a question on. So aspartic acid is fair game. Anything on here is fair game. And so you want to make sure that when by the time you get to testing, honestly, very early on, you have the structures of the amino acids memorized, because I should be able to look at, for example, the last amino acid on the right and see that we have a branched carbon chain, right? And I should be able to identify what amino acid that is. And so I want you guys to pause and think what amino acid that is. And so here we have isoleucine, right? And we should be able to identify every single one of those amino acids on test day when they come up.
I do want to kind of point out, a lot of students kind of like look at this and they may have all the amino acids memorized, and they look at this and they panic. They're like, wait, how do I even know where the boundaries are? Where do I see like where the amino acids are? I do want to point out that whenever you have the carboxylic acid of one amino acid that joins up with the amino terminus of another amino acid, right? So here we have one amino acid, and then here we have one amino acid. We end up creating an amide. And so whenever we're looking for a boundary between those, an amide is a good way to find that. So if you look at this, they made it easier here because they just showed you like, here's an amide in the backbone. And so that's a peptide bond. But if you look at this and just kind of like work through all of them, so this is one, 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 this is one. And so you should be able to kind of like go through here and see like, oh, okay, like this is one amino acid. This is another amino acid. This is another amino acid. And I know I've already said it once today, and I say it all the time, but amino acids are the highest yield thing on the MCAT. So you need to be able to look at this and know that this right here is glutamine, and the symbol for that is Q. Right? I know that that's weird, and I hate telling students to memorize stuff, but you got to know your amino acids really well. If you see amino acids mentioned anywhere in a passage or in a figure, you're going to get questions on it. And so Like there's a couple of things that I've seen kind of through here and just like the first paragraph and figure. And I'm already expecting like we're going to get some questions on some of the stuff up in here and down in here, just based on the figure itself, based on what they're mentioning. Now, I want to be honest. There are some times when the MCAT gives us paragraphs that there are not a lot of super testable stuff in here. So me saying like, oh, there's a lot of stuff that's testable here. Like some of you guys are like probably rolling your eyes and saying like, of course, like it's a passage-based question. There's questions on all this stuff. Not always. There are some paragraphs that are just complete fluff and not testable. But the fact that they mentioned the dimer and the 99 residue, so they could ask something about proteases and enzymatics, and especially the aspartic acid, as well as identifying the amino acids in this figure. Those are things that are really jumping out to me.
Honestly, I think the AAMC could have done so much more with this because we only have 4 questions for this passage, and we've already identified so many different places where they could ask us questions for this passage. So if I were an AAMC test writer, I would have gone ham on this passage. But at the same time, a lot of these things are foundational that you need to know. So they're going to have some foundational questions, but you can bet that they're going to have more complex and more integrated questions. And so just keeping that in mind as well as you're going through.
You're right, because there's only 4 questions here. And so obviously we know what they're going to be asking about. But some of the things I'm pointing out that I think are very testable are things that I have seen the AAMC test in other passages.
Yep.
And so like some of the stuff I'm pointing out, they might not actually ask a question on, but you should still be catching them because those are the sorts of things that the AAMC likes to test on.
Absolutely.
Yeah. So if we continue on to like the next paragraph, we have using molecular models of the HIV protease enzyme, researchers designed and synthesized transition state analogs. One such molecule is compound 1, shown in figure 2, which is a potent HIV protease inhibitor. Now, the MCAT is not as evil as sometimes students tend to think it is. Especially when stuff is a little bit trickier, they can make things a little bit easier and kind of like state things in a couple of different ways. I do want to kind of like take a moment here and let's forget the second sentence, that paragraph. And let's look at this. Using molecular models of this enzyme, researchers designed and synthesized a transition state analog. So the transition state, like trying to understand, like this thing is an analog of the transition state, whatever this compound 1 is. Like a lot of times students get kind of confused on like, what does that mean? If this is an analog for a transition state, is this a different form of this protease? And like a lot of students kind of think that, oh, this is something kind of like that protease. It's not. This is something that's kind of like the substrate because our enzyme will bind the substrate and then make it react. Partway through that reaction, we will have a transition state, right? And so this compound 1 that is shown here is something that looks like the transition state. So this is something that looks like the substrate of our enzyme. Now, without reading that second sentence, immediately students should be thinking, this is a competitive inhibitor, right? Because if you have some enzyme and it's got some substrate that goes into the active site of that enzyme, right? And there's a spot in there where it goes. And now all of a sudden you've got something else that can go in that site. All of a sudden these things are going to be competing for this, right? The red thing up top, like this is going to be our substrate. This, like the new thing that we've created, our compound 1, that's something that looks like that substrate. So it's going to bind in the same places that the substrate does. And so if you create something that is an analog of the substrate, that's going to bind enzymes and stop enzymes from working on other stuff. This is not just important for this passage. This is important for a lot of passages. This is also important for a lot of medicine because it turns out that this is a really good way to inhibit enzymes. specifically pathogenic enzymes. We use this to inhibit HIV. So people who have HIV, we're messing with that virus so it can't cause illness. We just give them some form of this compound 1 that messes with the enzyme, the virus enzymes. And so this is where treatments come from. This is why enzymatics is, okay, amino acids are the highest yield thing. Enzymatics is the second highest yield thing because it interplays into so much overall. And so this is why I'm like taking such a big moment here to just hammer on how important this second paragraph, the first sentence is. Now they do make it easier, right? Because they say, oh, like this molecule, compound 1, is a potent HIV protease inhibitor. To be honest, they didn't need to tell you that, and they might still expect you to figure that out. They were kind of nice here, clarifying that, like, this is an inhibitor. They didn't tell you what type of inhibitor. You should know it's a competitive inhibitor because it looks like the substrate, it's going to bind in the same place as the substrate. They're competing. So it's definitely something you want to, like, your alarm bell should be going off when you see that.
Yeah, I have nothing to add to that. That's exactly how I go through this passage as well, and specifically through this paragraph, because unlike, and I keep coming back to cars, but unlike the car section where if something is truly just out there and the author otherwise has very simple language, like here you are expected to understand this. And this is kind of a fine line in that sometimes, like we've talked about, they will give you something completely new that they don't expect you to have the context for, but the underlying relationship, the underlying or foundational concept, you do need to understand. So
Absolutely.
In this case, you didn't need to know anything about the HIV protease enzyme beforehand, but
right, or
the
this
transition state
compound
absolutely
specifically, right? Like you don't need to know this compound specifically. You don't need to know HIV protease, but based on what they're saying, you need to understand, oh, this is a competitive inhibitor that's going to help fight HIV.
Exactly.
Yeah, absolutely.
And so very quickly, like a lot of students will look at that compound 1 and freak out. But again, similar to before with the peptide bonds, we should be able to at least understand what groups are on here and how they relate to one another, right? And so right now, when we see this, we're not going to go and dissect this compound. When we see this on test day. If we get a question related to it, then we can come back to it. But on test day, it's not helpful to sit down, look at compound 1, and then start saying, okay, what exactly is every group on here? It's not a good use of your time.
Right. There's a lot of different questions. Now, you're right. I kind of skimmed over this. That's because how I would deal with it on test day. Will they ask you a question about this figure? Probably yes. Do you know what that question is going to be? Nope. Right. So it's not worth your time to go through and try to identify every single functional group and try to find out what's the molecular weight of this thing and whether it's going to go to the aqueous or the organic phase in an extraction. All of those are questions they could ask about. They do ask a question here that actually isn't any of those questions. And so it's not worth it. Like if they give you something with amino acids, like the other figure that we looked at, they're going to ask you about the amino acids involved in that because that's an amino acid thing. And anytime they bring it up, they're going to ask questions about it. It's hard to predict what that question is going to be. I'm going to keep an eye on it and note that that's there because there's probably going to be a question, but I don't know what that question is going to be. So I'll just wait. I will say there are a couple of organic molecules like this one. We said, oh, there's a lot going on here. We need to be able to identify the amino acids. And like we immediately identified what sort of things they could ask about this. There's not a lot here, but there are some molecules, things like ATP, things like cholesterol, things like heme. And you see these and you're immediately like, yep, they're going to ask me something about this because they expect me to know something about that. They don't expect you to know anything about compound 1.
Yeah. The moment I see glucose, I'm like, okay, here we go.
Yeah, exactly.
All right. So compound 1 has an in vivo half-life of 1.8 hours and is primarily metabolized by CYP3A, an enzyme in the cytochrome P450 family. So right off the bat, again, there are more topics that they could ask us about. We could get a question on half-life, right? That's fair game. Are we going to get a question on, the CYP3A and expected to have background information on it? No, right? But we have questions that are fair game here, and we have an idea of what the half-life is. Other than that, on test day, I'm going to keep going. The major metabolite, okay, so I'm paying attention here and I want to think the product, right? The major metabolite of compound 1 results from dealkylation of CH2R groups attached to the piperazine ring system, reaction 1. So now they're giving us a reaction. And so we want to at least take a look at it, right? But we are already told what it does. And I want to point out that a lot of times, if you're anything like, like some of us when we were going through a MCAT practice and studying, when you see either a functional group or some kind of molecule written out rather than drawn out, it can be a little intimidating. And so here they were nice, right? They gave us something very simple. When you see that R, you're thinking variable. But you can have very long strings of groups and a molecule with lots of functional groups, similar to how we looked at the first figure and were able to have an idea of what was, what groups were involved, and in that case, what amino acids were involved. You should be able to take a look at that long form and identify what's going on there as well.
Yeah. I do think that there's a lot going on in this paragraph. I think just overall, like looking at this, there's like they bring up like the half-life, they bring up the CYP3A, which is what I'm going to call it. They bring up cytochrome P450. They talk about the metabolites. They talk about dealkylation. And there's a lot of things in here that like are kind of going through my head of like, ooh, there's just a lot here. Mm-hmm. I redrew my little quick sketch that I probably would have done from that first paragraph. I probably wouldn't have added a lot to it, except for maybe showing that like compound 1, like this thing can bind compound 1 instead. And so it's a little bit of a competitive inhibitor, right? That it has to choose one of these or the other. And so it binds them kind of competitively. But then when they go into this, right, this paragraph, I might do another little bit of an expansion on this quick sketch, trying to show what's happening with this, right? And so this looks like a chloride, so I'm going to make that compound 1, so it's a little bit easier to see. But I would probably jump in here because they say this compound 1 can be broken down by the CYP3A. And so this can be broken down by the CYP3A. Into like, this is just metabolizing or like breakdown. And they do kind of give you, an idea of like what that looks like when they break those things down. And they could ask you to relate that to this figure. Once again, I'm probably going to wait until I get that question before I like spend a lot of time on it. But the MCAT likes to ask a lot of questions. Like if I gave somebody a CYP3A inhibitor, how is that going to affect the overall HIV virus infection in this patient? Like, is the infection going to spread more rapidly or less rapidly? And like, that's a really complex thing because it's like multiple steps in there. And so this is kind of another question that you could be predicting. But having a quick sketch helps you understand, okay, if I have more of this, then I'm going to be breaking down compound 1 faster. And if I'm breaking down compound 1 faster, like then my HIV protease is going to be doing its normal reaction instead of like the compound 1 being an inhibitor. And so giving a CYP3A inhibitor would actually speed up the HIV to be like doing the stuff that it normally is trying to be doing and trying to be an infectious viral agent. And so a quick sketch like this can really help me solidify this in my head. I also really encourage students when you're practicing, doing sketches like this will also make it easier to understand the passages and being able to like visualize this, which is something that's very important in cars, kind of making that connection with visualizing. But you want to be able to kind of understand what you're reading, right? Like it is very difficult to understand this paragraph. And that's not your fault. Like, I'll be completely honest. Like, I graduated with a biology degree and I had read like 3 journal articles, right? I'm probably exaggerating, like maybe 1. And that's like, so it's a little bit unfair for them to be throwing these really heavy passages at you and asking you to figure them out. And that's why it's really important to review these. And so a quick sketch like this really helps me understand what's going on with this interaction overall.
Absolutely. And again, I think it's really worth emphasizing, like, you didn't need background information on CYP3A to be able to work your way through Phil's question conceptually, right? Or whatever question the AMC might ask. And so this is also the kind of thing that you should be doing when you're practicing and coming across content for the first time, the second, the third time, even before you test, because that's going to make it a lot easier when you get to a practice exam to be able to do what we're talking about here and to make a schematic of what's happening in the passage. And even though we're on ChemPhys, I also want to say I found this super helpful in biochem.
Yeah.
And so making sure that you get comfortable doing this, huge lifesaver.
Yeah. That's one of those things that, like, the old MCAT, I say old, like pre-2015, like, it's a chemistry passage with chemistry questions, and bio passage with bio questions, and physics passage with physics questions. Now everything's all mixed up, and everything has kind of a bio spin to it. And so even in the ChemPhys section, like, you have stuff like this, which is a lot of biochem. And this is a passage about, like, inhibiting, like, a virus and slowing it down. And so this is absolutely, like, something, like, I would definitely use this in the other sections of the test, except for cars, because there's not a lot of weird data in cars, but you have kind of different strategies when it comes to mapping what's going on in the passage in the cars section.
Yeah, I love that you said that. I feel like students don't realize this, but if you actually look at what the AAMC says about the title of the ChemPhys section, we shorthand it to ChemPhys. It's of biological systems. That's the end of this. So I think that's a huge thing to keep in mind. So I love that you mentioned that.
Yeah. Okay.
Shall we wrap up this passage?
Yeah. So let's go ahead and finish up the last little bit here. Let me erase this. So one of the main side effects of prolonged use of compound 1 is the formation of kidney stones composed of calcium oxalate, CaC2O4. Once again, alarm bells are going off. All of a sudden, we have something about kidney stones and, like, calcium oxalate, and this screams like solubilities, kidney stuff. Solubility is a chemistry topic, and we're in the ChemPhys section, so that's making me think, ooh, there might be something going on there. And so definitely something that is sending up some alarm bells, where all of a sudden now kidney stuff is on the table for questions and solubility stuff is on the table. So researchers use their knowledge of the HIV protease active site and the metabolic pathways that lead to the destruction of compound 1 to design and synthesize several derivatives of compound 1 in an effort to modify its properties and increase its potency and half-life. That last paragraph here, or that last sentence, that's one of those things, like I was saying earlier, I don't think there's a lot to test in here, other than, like, we, like, modified into some different versions to, like, try to make it better. But, like, they didn't give us any data on any of this. They didn't give us any proposed structures. They didn't give us anything overall with this. Just saying that, like, hey, we're trying to do better. They're not going to ask, like, should we try to figure out better ways to make this work? Or did they try to modify its properties, right? Like, they're not going to ask any questions on that. So this paragraph is something that is, I think, this sentence here is something that is completely useless overall. I really like to point this out to students, because a lot of times students are concerned with timing. And when I have a student that has problems with timing, most often their issue is they're getting sucked into stuff that doesn't matter and isn't testable. And they're putting in a lot of time and effort trying to go through things that they really shouldn't be. Like that last sentence there, you shouldn't be spending a lot of time on that. Just like this figure 2, you shouldn't be spending a lot of time on that in your initial go through in the passage. You should wait to see what questions you have, if any. Like, you could spend your time figuring out the molecular weight of this molecule, and then they never ask you about it, and then you just wasted like 90 seconds going through that. So there are some places where you can kind of shave some time off and work a little bit faster, but understanding, like, overall how these things work is something that you definitely want to be able to do.
You said something here at the end. It's like, at the end of this passage, it's okay, we tried to do better. And it's honestly basically the end of every scientific journal article, like, oh, and additional studies are necessary, right? Or additional research is necessary. And so no shade thrown out there. But, like, that's honestly what most of them are. And so I find that it can actually be helpful for students to read a journal article. Like if you've never read one, go in and find something and read it and see what it's like, right? Because this is the basis for what you're going to be doing later on, but it can also just give you some really good insight as to the structure of how they might present information. And this does not mean go out and become a world-leading expert on HIV protease reading scientific articles, right? But it might be good to throw one in there every so often and challenge yourself.
Yeah, I do want to kind of remind students, I know we've talked about this a lot, but like review is really important. There's a lot of times a student will read this passage, do the questions, and then just review the questions they missed and not even look back at the passage. Like if there's a student out there who didn't understand how CYP3A like actually can cause viral infections to spread faster in the case of HIV, like then you missed something in the passage. And you should be reviewing that because that could have been a question. That would be a question with a different passage. So hopefully you guys are like, there's a reason we're going through this kind of so slow, talking about like, what am I taking from this? How am I thinking about this? Because like, obviously we don't spend this much time on the actual test doing this, like verbalizing it slows it down. But if you're trying to develop these skills, you don't need to be fast initially, but you need to still make sure that you're understanding it so that if you see a passage like this on the day of your actual test, you'll be like, I see what they're doing here. They said this was a substrate analog. That thing's a competitive inhibitor. No way I'm falling for that. So let's go ahead and take a look at the questions here.
Absolutely.
That's where the points actually are.
Mm-hmm. So question number 1. Compound 1 is used to treat HIV infection based on its ability to act as. So right off the bat, we know what's going on here, right? When we read carefully, we recognize exactly in this paragraph, we recognized what compound 1 was doing. And so there are actually a couple of things words that can come to mind even before we read the questions, right? Transition state analog, the fact that it's being used to treat HIV, the fact that it's a protease inhibitor, competitive inhibitor, all of these things should be coming to mind as we get ready to look at the answer choices. And so,
absolutely.
And so a lot of times students will feel the need to immediately go back to the passage. But notice that when you read carefully, right, and you understand the fundamentals and the relationships of what's in the passage, and you have kind of that starting point, you don't need to immediately go back to the passage and start digging, okay, what did they say about compound 1? Because guess what? They said a lot about compound 1. And so this is another place where you can shave time off and become better at your approach to questions, your strategy, and ultimately gain those extra points because you get to the end of the section.
Yeah.
So
absolutely. I just want to chime in and echo, yep, exactly.
So looking at the answer choices, so A, an agonist, B, an antagonist. Well, they gave us polar opposites, right?
Mm-hmm.
And so when the AAMC does this, you should already be thinking, if one of these is correct, the other one cannot be correct. And I need to think about, okay, what's the difference between the two? So an agonist is going to cause something to do more of what it normally does. Right. And an antagonist is going to prevent it from doing what it normally does. Well, guess what? We were told that it was an inhibitor, right? A transition state analog. So definitely not an agonist, right? It's not causing anything to happen more. If it were causing something to happen more, it'd be really odd that it's being used to treat HIV, right? So all of these things are working together to make A seem ridiculous, right? In the grand scheme of things.
Yeah.
And then we look at a placebo. So what does a placebo do? Nothing really.
Nothing.
Right? In the sense that that's why we say, oh, that's a placebo effect, right? You give, for example, you give someone medication and it doesn't actually do what you're telling them it will do. You're just trying to see if there's the power of what the power of suggestion is in that case. Again, that would be really bad for treating HIV, right?
Yeah.
And then a catalyst. So we said this is an analog for the enzyme. We said that it's like a substrate.
Yeah, so it's an analog for the substrate, right? Not the enzyme. I think you said it was an analog for the enzyme. Yeah.
So it's like the substrate for the enzyme. It's an analog of the substrate. And so a catalyst would imply that it is an enzyme. We know that that is not the case, right? We know that it is like the substrate. So that's also out, which leaves us with an antagonist. this makes sense. We were told that it's a protease inhibitor, right? The transition state analog, and it's being used to treat HIV.
Yeah, I really like the way you kind of went through that. There's something I like to call MCAT judo. So I'm going to do a little sidebar here. If you're boxing somebody and they weigh 100 pounds more than you, you've lost, right? Like you've pretty much lost that. All things equal, like bet on the heavier person. They're probably going to win. But in judo, you use your opponent's weight against themselves. And so I like to call this MCAT judo because you're using the exam against itself, right? And so looking at this, A and B are opposites. It's really hard for both of those to be wrong, because if one of them's wrong, the other one's probably right. There are exceptions to this, but generally speaking, if you have two things that are opposite, you kind of want to pick one of those or lean towards one of those if you are otherwise confused. You're right. Placebo makes no sense. Catalyst, I mentioned as we were going through the passage that a lot of times when people read transition state analog, they think analog for the enzyme, right? And they get that flipped around. And those students are going to pick D because they're reading too quickly and they're kind of like missing that little piece of detail there. So we don't want that to be you guys. So that's why we kind of like go through this like, wait, what is this an analog for? The substrate or the enzyme? It's an analog for the substrate.
This is also where familiarity can bite you in the bum because you've seen a lot of mention of enzymes, right? And so you might think, oh yeah, catalyst. I know we talked about that. We didn't talk about agonists or antagonists, but this is where knowing what something is and different ways that they can refer to the same thing or to classes of the same thing is really important.
Absolutely. So if we go ahead and look at question number 2, this is one of my favorite questions. It's a math question. Like how many stereoisomers of compound 1 exist? We knew they were going to ask a question about this. I think I suggested 3 different questions they could ask about this. This wasn't one of them. So this is like a different question. And I think that this is absolutely fair game. So whenever you're looking for stereoisomers, the answer is 2 to the N. And that's something you need to know just kind of outside of that, based off of where N is the number of chiral centers. Now, I have a little bit of a shortcut here for you guys. You could go through and like every single compound, because you have to, like in order to be a stereoisomer, you have to be attached to 4 different things, right? And so anything with a double bond isn't going to work. So that doesn't work, that doesn't work, that doesn't work, that doesn't work, that doesn't work. This has got 2 hydrogens, and those are the same, so that one doesn't work. This is a nitrogen, it's got a lone pair, so it's not going to be attached to 4 different things, so that doesn't work. This carbon's got 2 hydrogens, that doesn't work. Same for this one, same for this one. This one here is connected to 4 different things. This carbon's connected to 3 things because the double bond. This nitrogen's got a lone pair, so that's out. This one's out. This one's out. Like each one of these are out. So I could go through every single one of these one at a time and try to figure all of that stuff out. But if they show you dashes and wedges, that means that has to be a chiral center. Otherwise, why would they specify? Is it coming towards your way? Like the only time you would ever specify that is if it actually mattered, which means it would have to be a chiral center. And so there's a little bit of a shortcut to the question. And I've seen the AAMC do this multiple times. I don't know why, but like they do this honestly kind of all the time. They ask like about the chiral centers, but they give you the molecule and they leave in the dashes and wedges. There's 5 of them here. So the answer is 2 to the 5th. So that's 2 times 2 times 2 times 2 times 2. 2 times 2 is 4. 2 times 2 is 4. 4 times 4 is 16. Times 2 is going to be 32. So the answer is C.
I like how you went about that, because just like the math, it just shows the different ways our minds work. I'll get to that in a second. But right off the bat, like just thinking about it, you can also just get rid of A and B right off the bat too, because that would, like you said, there are 5 places where you have that dash and that wedge. And if they wanted to be really mean, right, they could have one that didn't have those. And so you'd have to think about it a little bit more. When I go through these, so I actually hadn't thought about that. And I really like your approach to this. I look for whatever has 3 like either 3 or 4 lines on it explicitly, because anything that has just 2 connecting points will not be the case. And so you can let your eyes glaze over that and just look for the ones with 3. And then if it's a nitrogen, probably going to be out, right? Because of that lone pair. And so it actually can simplify it a lot when you're going through. And when you are reviewing, you should absolutely go back and make sure that which ones are a chiral center and why. As for the math, I like how you did like 2s and 2s. My mind says, okay, 2 to the 3rd, I know is 8, because there are some that you should already know. And then you double that twice, you get to 32. But there are definitely some numbers, some calculations that you should be able to see them and not have to think about them on test day. And so if math is somewhere where you struggle, or if you've struggled with, more basic math in the past, I would encourage you to sit down and do some math practice, get math practice, because you don't get a calculator on test day, and you might not have taken math since freshman year.
Yeah. And you're absolutely you should use your scratch paper. I do want to point that out. If you need to, don't try to do stuff in your head. You've got enough stuff to do in your head when it comes to the MCAT anyway. Use your scratch paper where it's at all useful. But yeah, absolutely. And I did kind of do that maybe a little bit differently. I know a lot of people will be like, well, 2 times 2, that's 4. So times 2, so that's 1, 2, 3. That's going to be 8. Times 2, that's going to be 16. Times 2, that's going to be 32. So that's 1, 2, 3, 4, 5. 2s multiplied by each other. I like to just kind of write it out and just okay, these 2 and these 2, and then multiply those and multiply whatever's left. But there's lots of different ways to kind of do that. I do want to say, like you said, this is a good way, at the very least that these 5 are chiral centers. I think doing a last minute skim, do you see anything with 3 things coming off of it where one of the things isn't a double bond? There isn't any. And so it's just those 5 overall. All right.
So question number 3, how do kidney stones form in some individuals treated with compound 1? So we knew that they could ask us something about this, right? And we knew kidneys were fair game, right? Nephrons could be fair game. Solubility could be fair game. And so this is what they've thrown at us, right? Now, again, a lot of students are immediately going to be tempted to jump back to the passage. But guess what? There are answer choices we can eliminate without needing to go back to the passage. And so that instinct to run back is not always necessary. Take a look at what's in front of you before you go right back. So looking at, we're gonna read these. So looking at A, so we have calcium plus C2O4 with a 2- charge is greater than the KSP. I'm looking at that and something is off, right? Where is that plus sign coming from? It's a solubility what? Solubility product. So when I'm thinking of a product, I'm thinking multiplication. That's just silly, right? They're trying to see if we can pay attention when we're looking at that answer choice. Then I have the same compounds greater than the KSP in B. So that would suggest that there is a precipitate forming there. Looking at C again, we have that plus, it's out. I'm not going to fall for that trap, right? D is the opposite of B in that one is greater than the KSP. So the product is greater than the solubility product, and the other it's less. And so if I want to think about, okay, which one would cause a precipitate to form, I don't want it to be dissolving, right? And so I know I can get rid of D just because of the less than symbol. And again, we didn't need to go back to the passage. Now, they could also add another layer to this and give you different compounds in the in each answer choice, in which case you do need to make sure that you have the appropriate components compared to the passage. In this case, they didn't, so we don't need to go back. But if you saw that they had different products, then yes, go and take a look and make sure you didn't miss anything.
Yeah. I think that there's something really smart about the way you're approaching this. There are some questions on the exams that are even like tied to a passage that I don't think you even need the passage to answer this question.
Not
Right?
at
Like
all.
you could answer this question without reading the passage at all. As long as you understand KSPs, because you get like precipitates forming, like kidney stones forming whenever the concentration of these things is too high, and it's got to be a multiplication because that's how solubility product works. I also want to say, if those of you who like get kind of tripped up, you like can't remember if it's B or C, like you could stop and say, okay, when would I expect to get precipitates? When I have a lot of solutes in there or a little bit of solutes, right? A lot of solutes. And so like the concentration of calcium and the oxalate is really high. That's when you should be getting kidney stones, right? When those numbers are bigger than something, right? There's some amount that we can have kidney stones form, or like no kidney stones, but if you get too high, then kidney stones will form. That amount that the water can hold or the urine can hold would be the KSP. That's a measurement of what's going on there. This is one of those questions that really requires some outside knowledge. You have to understand solubility stuff. And I think that it's really important for you to understand when to go back and when not to go back. And this is kind of what you were touching at. This is something that's kind of weird about the sciences compared to the cars. I know we're doing a lot of like comparison between those two. But in the sciences, you have to know stuff. There are some questions that need to come, the answers come from your head is where the answer is. Like if it's not in your head, then you can't get the answer. You got to know about solubility stuff. There are also questions, like if they had asked me some question about the way that the HIV protease interacts with substrates, like, is that something I'm supposed to know about? Nope. Right? That is outside this box of information that the AAMC is holding me accountable for. How does solubilities work? That's something in the box. This is why, like, if you see enough questions, there's some questions that I'll look at and I'm like, the answer's in the passage. I just need to go find it. Like, there's some line somewhere in here. I don't know what it is, but the answer's got to be in the passage. When they start to ask about a specific enzyme, a specific bacteria, a specific something like that, specific drug or medication, like I'm not supposed to know about that. But when they ask about generalities of like the sciences, all of a sudden, I know the answer needs to come from my head and I need to not go back to the passage because the question isn't there. Students tend to lean one of those two ways, where they tend to like over rely on their head or over rely on the passage. And that's something that's hard because like both of those are things you have to do at certain times. I think it's really important for you to identify which one are you. I'll have a lot of students that I'll like ask. I'll have two students. I ask them the same question about the same passage. One student will go, hang on, and they'll like look at the passage. The other student will be like, hang on, and they'll like look up and like start to be like thinking. And it's like, I can tell like which one you are. Like, do you tend to go into your head too much or do you tend to go into the passage too much? It's important for you to identify which one you are so that you can try to shift back, because there are times when one strategy is correct over the other one. And which one is correct depends a lot on the question. So it's good to try to do that. I have a lot of students that are very smart and they over rely on their heads because they're used to like solving everything in their heads because that's how they do everything in their life. They're really smart. They're really on top of it. And I'm just like, no, the answer was in the second paragraph and you just didn't go back. And so you missed the question. And so you got a really bad score because you're trusting yourself too much, which I hate to say. But some students do that for like the wrong questions when the answer's in the passage somewhere.
Absolutely. Quick plug. Drink your water. You do not want to end up with kidney stones.
Absolutely.
But yeah, so I think this is something where when you're figuring out why you're missing questions, this is a great opportunity, like you were saying, Phil, to figure out what you can improve on, because it's not always content for the sciences. Sometimes it is and sometimes it isn't.
Yeah, that's why it's really useful, like to have tutors, to look at data, to analyze, to review, to like find like what is the way that I'm approaching this that is incorrect. Mm-hmm. Okay, so we got one more question. Question number 4. It's our last question.
All right.
So is it me or you? I forgot.
I think it's you. I just went through the kidney stones.
So this question, so the peptide bond between which two amino acid residues is cleaved by HIV protease? This is the question we saw coming from the very beginning, right? They're asking about like where this protease is cleaving. This is one that I am not expected to know this answer. Like, how does HIV protease work? Not in that box of information I am responsible for. So the answer is in the passage. And if you go back to the passage, you can identify, like, what are these amino acids? We have them here. We have them here, right? So looking at this one's pretty easy. It's got a phenyl group. So that's going to be phenylalanine. And so, like, I immediately want to cross off B and C because neither of those have phenylalanine in them. The other one is kind of a strange one. Says every single amino acid has like a carboxylic acid area, an amino area, and then an R group, right? Just quick plug. That's why they're called amino. They have an amino group and a carboxylic acid, generally an OH. But when you form a peptide bond, that just attaches to the next nitrogen. And so in this case, our R group is weird and kind of like goes back around and grabs onto the nitrogen. And so there's only one amino acid that does that, where the R group reaches around and grabs onto the N, and that's proline.
Which is my favorite amino acid.
Yeah. It's really weird. It's a very important protein because it induces kinks in chains. And so, like, this is really just coming back to this question we saw coming from a mile away. It's just like, oh, that's proline and that's phenylalanine. So the answer is D. There's no valine and alanine, no valine, no alanine in here. So that makes it a pretty easy question if you, and like this is, like I said, this is a question you should have seen coming from a mile away.
Yeah. And hopefully after working through this first passage, you'll realize the importance and the benefit of a thorough read and looking for those buzzwords, looking for topics, looking for and thinking, what could they ask me about? Because that helps orient you to what do I need to focus most on, right? And when you get to the questions, when you've seen something like this coming, you're not freaking out, right? And a lot of times when students hit tough passages that are, more difficult reads, or they get to the questions and they're just like, what just happened? You can enter that kind of panic and anxiety state and miss questions that you should not be missing because you know the answer. And so if you can start spotting the questions and predicting questions for the sciences before they come up, you're less likely to have that kind of fear, frustration, fight or flight, right, response when you get to these questions.
Yeah, absolutely. That's a really common thing where students will start to panic because, like, I don't know anything about HIV protease, and like, you're not expected to. They might ask you a question about the HIV protease, and then you just got to go to the passage and it's in there somewhere. Now, there are stuff that they will expect you to know. That's why it's really important to have a good content foundation. Like, to answer like these questions, you had to know your amino acids really well. You need to know solubility stuff. You need to know some enzymatic stuff with like an antagonist and inhibitors and things like that. So there are definitely some things you do need to know. What was the second question? Oh, like how the formula for stereoisomers. So every one of these questions kind of required you to know something, but some of the questions, like, you still need to go back to the passage to deal with. Some of the questions you don't need to, and you can just straight up be like, precipitates form when the products are bigger than the KSP. And so the answer is D because it's the only one, or B, I think was the right one for that one. So hopefully this makes sense. I actually think that this passage is a good starter passage because this is not, like, there's not a whole lot of data interpretation here. I don't think this is the hardest passage that the AAMC has ever released by a long shot, but there's a lot of stuff in here that you see all the time, over and over. This is a classic MCAT passage, asking about amino acids, asking something about a big complex structure, tying it into some chemistry or physics thing, in this case, solubilities. It's a very classic sort of passage. We're going to be looking at some other ones in the future that have some tricky data interpretation. And hopefully you guys are getting like having a moment to like start to get some insight into the test writers and what you should be thinking as you're approaching stuff. I think it was question number 1, where the test writers know that students get tripped up between like substrate analog and enzyme analog. And that's why answer choice D is there, is because the test writers know students get confused on that and they're going to pick D. And so that's their way to try to separate the people who really know enzymatics and are good at reading carefully from the people who like maybe are reading too quickly and glazing over some important stuff. So I think I want to make sure to be hitting that in every single one of these videos is like, how are the test writers grading these questions? How are they structuring it so that you can start to get some insight and you can see the traps coming and you can sidestep them because you're like, nah, I see what you're doing. I'm not falling for it this time.
Exactly. I'm really excited to get to the next few passages. And as always, we have so many resources available on the Jack Westin website in case you found us and this podcast before you found. Thank you for joining us, and we will see you next time.